Do some questions today. Pause the video for some time and think about the question. If you get the solution, great. If you don't get upset. Let's do it together. Let's start doing it. Solution of 1. The question says, in the expansion of x plus a to the power n, if the sum of odd terms be p and sum of even terms be q, we need to prove that p square minus q square is equal to x square minus a squared whole power n. Let us expand x plus a to the power n. That gives us x to the power n plus nc1 x to the power n minus 1 a plus nc2 x to the power n minus 2 a square, so on till ncn 8 power n. Now when we group the terms, the odd terms basically, you get x power n plus nc2 x power n minus 2 a square and so on. What we're doing is that we're grouping the odd terms together and the even terms together. And the even terms will be nc1 x to the power n minus 1 a plus nc3 x to the power n minus 3 into a cube and so on. And from the above expression we know that this is p plus q. Now let us expand x minus y, x minus x minus a to the power n. So what does this basically give? It gives us x power n minus nc1 x power n minus 1 a plus nc2 x to the power n minus 2 a square and so on. And when we group the even and the odd terms, what we basically get is x power n plus nc2 x to the power n minus 2 a square, so on, minus nc1 x to the power n minus 1 a plus nc3 x to the power n minus 3 to a cube and so on. And that gives us p minus q. Now let's go to the condition. P square minus q square is basically p plus q to p minus q. So when we do the simplification, you get x plus a the whole power n to x minus a the whole power n. From the above result, this gives us x square minus a square to the whole power n. And voila, we have proved the first part of the question. Now let's prove the second part. What we need to prove is 4pq is x plus a to the power 2n minus x minus a the whole power 2n. When we substitute 4pq is basically from the expansion of p plus q the whole square minus p minus q the whole square. On substitution, we get x plus a to the power 2n minus x minus a to the power 2n, and we approve the result. Let's move on to the next question. Question states, show that 100 plus 1 to the power 50 is greater than 100 power 50 plus 99 power 50. Pause the video and take some time to do it. Let's continue. 100 plus 1 the whole power 50 can be written as 100 power 50 plus nc1 100 power 49 plus nc2 100 power 48 and so on till plus 1. 99 can be written as 100 minus 1 to the power 50. So what does this that give? It gives us 100 power 50 minus 50c1 100 power 49 plus 50c2 100 power 48 and so on till 1. Now 101 power 50 minus 99 power 50 is basically, on substitution, when you subtract these two, you get twice of 50c1 100 power 49 plus 50c3 100 power 47 and so on. On further simplification, we get twice into 50c1 100 power 49 plus 2 into 50c3 100 power 47 and so on, which gives us 100 into 100 power 49 plus a positive number. This is greater than, this whole thing is greater than 100 power 50. 100 power 50. When you simplify that even more, you get 101 to the power 50 minus 99 power 50 is greater than 100 to the power 50. On further simplification, you get 101 power 50 is greater than 100 power 50 plus 99 power 50, and that's our result that we required. We proved it. Let's move on to the properties of binomial expansion. As discussed earlier, there are n plus 1 terms in an expansion. And second point, since NCR is nothing but NC r n minus r, we have NC0 is equal to NCn, which is equal to 1. NC1 is equal to NCn minus 1, which is basically 1. On further simplification of this or this, you get this result. We also know that NC2 is NCn minus 2, which is n into n minus 1 divided by 2 factorial. This result is very useful in many questions. Let's move on to some interesting questions, like the coefficient of x to the power 7 in the expansion of ax square plus 1 by bx power 11. So how do you do this kind of question? It's fairly simple. we take the general term. Since this is 7, is a t of r plus 1 and n is 11, so 11c r ax square to the power n minus r plus multiplied 1 by bx into r. So this can be further written as 11cr ax square over n minus r to bx to the power minus r. The coefficient of x power 7. So x power 7 means a power n minus r x to the power 2 of n minus r into b of minus r into x to the power minus r, and this should equate 7. So 2 of n minus r should be equal to 7. 2n minus 2r minus r should be 7, and n in our case is 11, so 22 minus 3r should be 7. 22 minus 7 is 15, so 15 is equal to 3r, and r is roughly 5. So the term will be sixth term, and on further simplification we get the coefficient as 11c5 a to the power n minus r, n is 11, 11 minus r is 6, divided by b to the power minus r, and r is 5, so b5, and this is the coefficient of x power 7. Let's say we need to find the middle term. So how do we calculate the middle term? It's fairly simple, though it looks quite difficult. When we are finding the middle term, there arises two cases: when n is even and when n is odd. Now let's take the first condition, when n is even. When n is even, the middle term in the expansion of x plus y to the power n, since the total number of terms is n plus 1, which is odd, since n is even, this whole expression becomes an odd number. The middle term is only 1, and it is n by 2 plus 1. The 1 comes since we are including 0 2 from this expression nc0, so that's the reason the term number becomes 1 extra. So this is the only middle term present in the expansion of this. So t of n by 2 plus 1 minus 1 plus 1, since this is r, so that's n by 2 plus 1. So t of n by 2 plus 1 is n by 2 nc n by 2 x to the power n minus n by 2, that's n by 2, and y to the power r, that's n by 2. So that's the middle term. My handwriting becomes very bakwas. Let's go to the second subcondition, when n is odd. When n is odd, n plus 1 will be even. So there arises two middle terms. which are roughly n plus 1 by 2 and n plus 3 by 2. Now let's take the first thing. Since this is a middle term and this is a term number, so r plus 1 is equal to n. So in this case r plus 1 is equal to n by 2 plus 1 half. When this goes over there, our r becomes n minus 1 by 2 plus 1 is equal to nc n minus 1 by 2 x to the power n minus 1 n by 2 minus 1, which gives us n plus 1 by 2 into y to the power n minus 1 by 2. And this is for the expansion of x plus
it's
y
9 o'clock.
to the power n. Now the second term is t of, on similar calculation you get n plus 1 by 2. So that basically, one second, n plus 1 by 2. So it gives us nc n plus 1 by 2 to x to the power n minus 1 by 2 into y to the power n plus 1 by 2.